Hello everyone and welcome to another video. In this one we will continue to work on terrain generation. Yeah, so basically we currently have this. Let me just show you what we currently have. So we can build and execute the client, that is correct. Cool. So we basically have this world, right? Let me just decrease the zoom so you guys can see see it more or less. Yeah, so this is basically our world. The world is going to be much larger in the final game. It's probably going to be like 20,000 blocks wide or something like that, probably even more. But we are currently just testing things and algorithms and techniques with 256 tiles wide. And basically what I want to do today is to add the concept of stone. The final game is going to have different kinds of stone, like in real life, right? But for now, we're just going to have a simple stone, so we can test the techniques to generate like stone patches here or patches here, like minerals, gold and stuff like that. And yeah, so I think we can start by testing a technique I learned a few months ago on something unrelated, and that is called the Drunkard's Walk or something like that. I have the Wikipedia open here. So it's basically, this is the name, Drunkard's Walk. I don't know. It's not, English is not my first language, but yeah. So basically, a random walk where you basically put you pick a position, and then you let your entity walk randomly in directions until it reaches a maximum distance from its initial point, right? And I think that this approach is going to generate some pretty good like patches that seem relatively natural, right? And that is going to be useful for placing ore veins, right? So coal veins and stuff like that. So this is a lot of equations that I don't care about, right? So as always, let's ignore Wikipedia, right? And let's just program from intuition, because I think that's the best thing we can do, to be honest. And actually, first, before doing that, I would like to add the concept of water oil. Do I want to add a concept? Yeah, probably not. We can leave water for the next videos. Okay, so here, let me just make sure this is clear. This is 1D midpoint displacement, and I can call age like, well, yeah, this needs to be age. Oh, but this is the displacement, right? Displacement. I can call it displacement, and I don't need these comments any longer. Okay. So now we need another technique, right? We need another technique, and this technique is going to be the one I mentioned. So let me just, well, do I want to call it this name? Because this is going to be hard to type because I don't even know how to pronounce this. So I'm probably going to call it random walk, I would say, yeah. So this is a random walk, and this is going to work in 2D, right? So it's going to, yeah, the entity is going to walk in 2 dimensions. So the first thing we need is probably X and a Y, I would say. Okay, and next I would also want to have like a filler, right? So as while the entity is walking around, it's going to change the current tile to a different type, right? So I probably want something like this. Have a struct, actually an enum that contains the solid type, like so, and it is basically going to contain this, right? Oops, right, yeah. So, well, I call it kind here. Well, I can call it type. Yeah, actually, yeah, I can do that right away. I can say something like include standard int. Yeah, standard int, and here I actually want to have these only occupy a few amount of bytes, because since we are going to have such a massive planet, and I don't want to use chunking system, right? I want to keep the entire planet, the entire terrain, and all of the entities in memory. We need to be a bit careful with how much memory each tile uses. So I think for now, the type can use just 6 bits. So for now, each solid has 1 byte, but in the future it's probably going to have 2 bytes, and I think we don't need anything more than 2 bytes, but we need to think about that, to be honest. Oh yeah, I forgot this. So I had this opened at the beginning because of this. So when I programmed the server, I don't know if you guys remembered, we used 128, but then I was researching about it, and there is actually a constant called somaxcon that basically holds the maximum amount of connections possible by the OS or something like that, and that's what we should use, if I'm not mistaken, right? So yeah, that's from the Windows header, and yeah, and the Windows header, by the way, is not really included here because it's already included in uv.h. And if I'm not mistaken, this should also work in Linux and stuff like that, but I still need to test it, right? But that's not the point of this episode. In this episode, we need to create a random walk into dimensions. Okay, so here I need to accept a type, right? A solid type. And this is basically going to be the type of the solid that is going to be assigned wherever the entity walks on, right? So here I actually just need to change this to type, right? And by the way, we are going to need for now stone. I can call it stone. Now, well, this is not really going to be stone in the future. In the future, we're going to have basalt, andesite, and stuff like that, you know. So, but we can keep it like stone for now. And since I'm at it, I can also add like the stone case here. And what kind of color do I want for the stone? Light gray or gray? Probably just gray, right? I can probably just print with gray. Okay. So now the random walk. I'm thinking about something very simple. So, oh, and I also need, by the way, I have an x, a y, distance. Right. So this is the distance that the entity needs to, the maximum distance the entity can walk before it dies, right? And I think that's everything. So I think we can just iterate through the distance. Right? And I'm not going to need I for anything, I think, because here, this is actually not constant. This is actually mutable, because here I basically just need to come here, and the terrain at x, y dot type is going to be equal to solid type, and then we need to move the entity, right? And to move the entity, I'm just going to do something very simple. I'm just going to add a random value between -1 and 1, right? And -1 inclusive and 1 inclusive as well, right? So the entity can move either left, right, or stay in the same place. That's basically what this line means, right? And here I can do the same thing for y, so it can either go up, down, or stay in the same place. Cool, and I think that's basically the entire algorithm, if I'm not mistaken. So we can test it. So here, this initializes the mountains, right? This initializes the mountains, and then I need to actually perform. I can perform a random walk. Where do I want to perform it? So for now, I can probably just say planet width divided by 2. Then I can say heights at that particular point, right? Then I can test it with a maximum distance of 10, I guess, and the solid type is going to be solid stone. And what is it going to happen? Oh, but this is, yeah, because here we are going to override it. Yeah, so actually this needs to be performed after this stuff, right? Yeah, so let's test it. What is this going to do? Okay, so as you can see here, well, this is not really the kind of thing I wanted. Right, let me run it again and see what it does. Well, this went upwards. I don't think I like, well, this is more like the shape I wanted, right? This is more like the shape I wanted. Let me increase the zoom once again, because now we actually want to see it up close. Oh, this is like, yeah, this is what I wanted, to be honest. This kind of shape, you know? So it's like a blob of stone, you see? It's like a blob of stone. Let me actually put it light gray, see if it looks better. Oh, it's much worse. I can keep it light gray. So the real random walk 2D, so the algorithm itself, the Drunkard's algorithm, it's iterative, right? So you are supposed to say something like for size t 0 is less than some amount that you want. I'm going to say 4, then I can increase it, and basically you are supposed to pick any block you previously walked on this iteration, right? But I'm going to keep it in the middle for now and see what kind of result this gives me. Okay, so this looks better, right? This looks much better. What about this one? Okay, that seems to be a reasonable blob of stone. Okay, I'm starting to like this one. You see, this is now generating pretty good blobs of stone, to be honest. Yeah, pretty good blobs of stone. So I think I'm going to keep it like this for now. We can improve it later. This is just a test, right? So we are just testing different techniques and composing them to form like a procedurally generated terrain that looks good and plays well, right? And it is fun to play on multiple times. So now I basically just want to generate multiple blobs of stone at like surface level, right? Uh, basically like I don't know the name, like inclusions of these stone blobs in the dirt section, because after some certain height we are going to have a stone section, right? But I don't know exactly what is the resolution, so we can test different resolutions. So let me think. So this is going to be the x, and x is less than 0. X is then going to be less than planet width, right? And then here I can probably say x plus equal get random value, and we can increment x by, I don't know, like 4, and I don't know, this is like a guessing game. This is always going to be all of this stuff is going to be configurable in the future, but now I just want to test the algorithm itself, right? In this episode I just want to test the algorithm itself. Okay, so if we do this, then we can use the x here, right? We can use x here, but we also need to pick a y, and I want this stuff to be underground, right? So the y of this needs to begin, it also needs to be random, right? It also needs to be random. So this needs to begin at the height of this, right? Probably plus some offset. I can put it at 3, and that plus some other offset that I don't know what it's going to be. I'm going to put it like 17. So I need to tune these parameters, and yeah, I can test this. Let's see what this generates. It crashes. Okay, so why does it crash? So why does it crash? That is very interesting. So this is x less than plus equals this random value. So does it crash every single time? No. Okay. Oh, we are generating some stuff high up here, which is not really what we wanted, right? But these kind of blobs of stone, they are pretty good, I would say. We can improve them. I don't like them to be very too dispersed. That's why I'm always starting the random walk at the same point, at the center point. But I don't understand why we are generating them on the sky. That's very strange to me. Okay, but here I probably need to increase the spacing. I'm going to put 16 and 32. Because I don't, yeah, this is probably better. Maybe too much. Let me decrease the zoom to 5 again. Okay, so did I get to... No, I'm not generating stones in the sky anymore. I don't know why I was generating them in the sky to begin with. That's strange. Oh, let me think. I probably need to clamp this. Yeah, I think I need to clamp this. So yeah, I probably need to say something like, I think relive as a clamp function. Oh, okay, I need to implement it myself. Well, we can implement clamp for integers. So minimum, maximum, and this can probably be the value, right? And so if value is less than minimum, then return the minimum. If value is greater than the maximum, return the maximum, and then I can just return the value, right? Because that's probably one of the reasons it was crashing previously. So here I need to do this, and then the minimum is going to be 0. I probably want to, yeah, I probably want to include that. So less, or no, yeah, that's correct. Yeah, that's actually correct. And the maximum will be planet width, right? And here I want to do the same with y. So y is going to be 0 and height itself, right? Yeah. Okay, so by clamping this should no longer crash, right? And should no longer generate like some really random stuff on the sky. Okay, so I probably want to increase the spacing. Let's say 10 and 20, right? In terms of spacing, I probably want to increase that. Okay, I probably want my blobs to be smaller, and to control the size of my blob, I just need to decrease the distance. Let me use a distance of 6. Okay, that's looking better now. And then I probably want to have this more dispersed, you see, in terms of height. So I can probably say, let me not add anything here. And here, let me put like 32. So it's going to, these blobs are going to appear at surface level and 32 blocks below it. Let's see what this generates. Okay, probably too much. I would say that's probably too much. Yeah. So let me say 16. Half of that. Okay. Okay. I don't know if I like these kinds of blobs. Let me increase this instead of 4 to like 6. So we are going to have 6 entities dying before this ends. Okay, it's setting somewhere. I probably want to actually have an offset here. Let me say 4. Okay, I think I'm starting to like this stuff. So let me increase the distance to 7. Yeah, I think this is generating more or less interesting stone blobs, I would say. Yeah, I kind of like it, to be honest. I kind of like it. So now, yeah, do I have time? I probably have time. So I can also like create the division for the stone. I'm going to do something very simple now. In the next episode or in the episode after that, I can do something more interesting. I can use midpoint displacement once again to determine the stone layer. But for now, I can probably just say, so this is height plus 1 and is less than, okay, so at what level do I want this to begin? Okay, so I can probably say y is less than, let me have I probably want macros for this kind of stuff. So this is the sea level. The sea level starts at 128. So I can have like a stone level, we can call it like that, and this is going to be the sea level plus 48, I guess. We can try that. So this needs to be less as well than the stone level, right? This needs to be less than the stone level. Well, I could probably, well, but am I going to have multiple levels? Well, I can probably compact that, because I can just say, so if y is less than planet's stone level, then it's dirt, otherwise it's stone, right? Stone. I can probably say that, and that's just going to work for now. So if I do this kind of stuff, okay, that's too much. Yeah, so to that, because I need to take in consideration that this is the sea level, so the displacement is, oh, the displacement is 32, so this needs to be much, yeah, so I have 32, then plus 16 is like 48, so yeah, plus 8, yeah, so I probably need to increase the height to 1048, and this needs to be, and that needs to be 128, so let's test it. Okay, that's still not enough, so that's why I wanted to have like a midpoint displacement based on the first one to actually have the stone. But for now, let me test it with 160 or something like that. Okay, this is completely flat. It's not supposed to be completely flat, but it gives you an idea of how this is going to look like, right? Let me decrease the zoom. Oh, this is not what I wanted. This is what I want. Okay, so if I go down, because now we have 1024 high planet, right? So, and we are still getting 44 FPS, and I'm not first time calling, right? So we are never reaching the end of the planet. Oh my god. What kind of... Okay, so I probably can just do something like this. I can just have size t draw calls, right? And here I can just increment the draw calls individually and then just return it and print it, probably. Cool. So here, well, for now, well, no, but this needs to be outside of the 2D mode. So I can say this is returning draw calls. So these are the draw calls, and after this, I can just say draw text, and this can draw the text at 15, 15, and oh, this actually needs a text. I think really has a text format, which basically works like printf, but it returns the text. And here I just want to use, oh, this, yeah, because this doesn't work with the most recent C standard. So let me convert it to a long int, or a long unsigned probably. Yeah, so I can use long unsigned and just print that as the draw calls. So the font size I can use 10, and the color can be green as well, like the FPSs. So how many draw calls are we doing? Oh, this is too small. This probably needs to be 20, 20, and this can probably double as well. So this is the X, I want 5, 25, and this can be dark green. Do we have dark? Yes, we have dark green. Okay, so we are actually drawing a lot of stuff. Well, yeah, 228,000 tiles, right? So, and we still have 44 FPS. So, I don't think this game is going to have FPS problems, right? Because no one is going to play the game like this, and we are never going to need 228,000 draw calls, because we are going to use first time calling in the future, right? So this is a completely ridiculous benchmark, yeah, because no one is going to play it like this. But yeah, so Raylib itself can hold up to these kinds of this amount of draw calls, right? So this is not going to be a problem. Cool. So yeah, so I think that's enough for today. We can increase the zoom once again. And I think that since we tested and benchmarked this game, right? This is still, my god, I can probably just use 256 for now and then fix it later, right? Oh, so the more I increase this, the less. Did I change this? Oh, yeah, I don't want planet sea level, I actually want planets stone level. That's why it was taking so many. Okay, so this is probably, yeah, so this is probably too much now. Okay, that makes more sense, to be honest. But we still need to have a large amount, because yeah, midpoint displacement adds powers of 2. So we're going to have 32 plus 16 plus 8 plus 4 and so on and so forth. And to cover all of the possibilities, we still need to have something relatively large, right? I think this is okay. So yeah, we can have something like, we can probably have 48 like I initially wanted, and this is probably going to be more than enough. Okay, so one problem with this implementation is that we are only going to have one blob of stone per like X, you see, like per segment, and I may want to have multiple ones, so we can do multiple passes of this algorithm. So here we can do multiple times, so we can pass multiple times through the entire width of the planet, and this is going to give us multiple blocks per segment, which is a good thing, I think. So yeah, but this is just a test, right? It's just a test. We're just testing different kinds of techniques. Okay, so I think that in the next video we should probably start working on first time culling, actually, so we don't actually do so many draw calls. Because as you can see here, we are currently drawing the entire planet at once, and that's a lot of draw calls. So yeah, I can say draw calls here, and this is going to, yeah, print it properly. Okay, so I think that's enough for today, and I see you in the next one. Thank you for watching.